Here we are with another SQL tutorial. The question in the forum was, why is the CPU time more than the elapsed time? Let's straight away jump into the demo to understand this concept. First, let's turn on statistics time. This statement, when you turn it on, will give you the CPU time and elapsed time for your query. Now let's run a very simple query. Select star from sales order detail. You're telling SQL Server to give you all the data that is there in sales order detail table in the AdventureWorks database. Now the actual execution plan is turned on, and note once again that statistics time is also turned on. When I execute this, and while the data is coming up, let's jump over to the messages tab. Let's first understand what exactly are these data items here. So what you see here is the CPU time and the elapsed time. CPU time means that how much time has SQL Server threads spent on the CPU. So this is like the CPU execution, CPU time spent. And the elapsed time here means that the amount of time it has taken your entire query to run, which means from the point we fired F5 or we started executing the query till the time the last byte of data was returned. Remember, the entire result set is being rendered in Management Studio. So I can see about, let's say, more than 100,000 records that were displayed in Management Studio. So of course that takes a bit of time. Let's go over to the messages tab here. So we are talking about CPU time versus elapsed time. Now this also means that elapsed time is actually inclusive of the CPU time, which means the CPU time here that you're seeing is actually included in the elapsed time, because elapsed time here means the total time your query has spent, and specifically how much time has SQL Server threads. For this query, let's say if I jump over to the execution plan, this is a serial execution. You can see there are no parallel operators, which means this workload was run using a single thread. So that single thread spent 453 milliseconds on the CPU. So in hindsight, and in most cases, you will see that elapsed time is always more than CPU time. So with this first basic premise, we are clear on what is CPU time and what is elapsed time. Now back to the question. Why is the CPU time more than elapsed time? Well, in this case, you can see elapsed time is more than CPU time. And I've told you that in most cases, you would probably see something similar. But there are cases when you will see CPU time being more than elapsed time. What does that mean? So that's the question which I occasionally see in the forum, and I thought I'll just address that with a simple demo. Now what I'm going to do here is just change the statement a bit. Select start from this table, order by line total descending. Let's go and execute this. So what we are doing is including an order by clause there. And in descending fashion, let's jump over to the execution plan. The first thing that you will observe in the execution plan is that now this is a parallel plan, which means SQL Server has implemented parallelism. Multiple threads are working together to execute this query. That's what it simply means. How many threads, etc. We'll get into those details later. Let's jump over to the messages tab. Now, if you see, CPU time has shot up a bit more. Now it is like more than a second. So you have like 1000 milliseconds, 1095, and the elapsed time is 2623 milliseconds. You can see that the elapsed time is still more than CPU time. So this obviously does not answer your question. Now I'm going to do something tricky. Okay, let's clean the buffers. So in this previous execution, when we did this with this query with the order by clause, one thing was evident. You saw parallelism in action. Keep that in mind. Now I write a query which is making some sense or no sense. That's fine. But there are some aggregations being done, group by and order by, whatever. I'm just trying to do more CPU stuff here. And then of course, look at that last line, order by line total descending. So I'm still doing that. Let's go and execute this. Execution plan is turned on and we can see our statistics. Now let's jump over to the execution plan. You can still see the execution plan here with parallelism. So you can see there are a couple of parallel operators out here. And of course the plan is different because the query is different. Let's jump over to the messages tab and let's scroll down. Now you can see that CPU time has gone even more up, 1638 milliseconds, and the elapsed time is 2104 milliseconds. Still, the CPU time is not more than elapsed time. So, which means we have still not come to the climax of the demo. What I'm going to do is I'm going to run this a couple of more times, maybe just once. And let's go and jump over to the messages tab and see if this time really CPU time is still not more than elapsed time. Okay, I'm going to do this once more and see if there is any impact, any change. SQL Server is dynamic execution, dynamic behavior. No, nothing this time. Let's do a trick here. Select top 10. I just want 10 records, but the overall execution of the query here, of course, all these computations are going to be done, but only 10 records are going to be rendered in Management Studio in comparison to 100,000 records, what we did earlier, right? If you look at the status bar there, we're talking about 121K rows. Okay, so let's go and execute this, and you just want 10 records. They come up very quickly. Let's jump over to the messages tab, and what you can see, now you can see that CPU time is more than the elapsed time. CPU time is 516 milliseconds and elapsed time is 321 milliseconds. Now don't get me wrong, first things first, this demo here does not mean that you have to put like top 10 or top 20 to get this kind of behavior, not at all. What we are trying to, I just did this as a trick just to kind of show you the demo. So what we are trying to achieve here is, my goal was to show you that yes, in your workloads, in your queries, when you are looking at these numbers, you can see that CPU time is more than the elapsed time. Now you know what elapsed time means, right? We're talking about elapsed time. So from the point you started executing the query till the time entire data was rendered in Management Studio. So of course, when you are rendering 120,000 records in Management Studio, SSMS not being a very fast client, it takes time. So the elapsed time goes up. The moment you say top 10 records, you're only wanting to render just 10 records in Management Studio. So of course, the elapsed time comes down considerably. So you can see like just 321 milliseconds versus 2000 milliseconds or so. However, look at the CPU time, almost kind of remains similar because you're still doing the same computation. You're still doing the summations, the aggregations, you're still doing the group by, you're still doing the order by, and of course your execution plan remains same. But again, the question is, why is the CPU time more here? What does this mean? Remember, we talked about in the very beginning of the demo that SQL Server threads that have executed this query, they have spent time on the CPU, on the logical processor, and they spent about 516 milliseconds. In case of parallelism, multiple threads are working and are spending time on CPU. So in this output, CPU time 516 milliseconds means that more than one thread have spent time on the CPU. And this is accumulation. It is a summation of all the threads spending time on CPU. How can you find that out? So let's jump over to the execution plan and let's take any operator. Let's take clustered index scan. Right click, let's go to properties here, and you can see actual number of rows there. So let's expand this, and you can see multiple threads in action. So you can see about 8 threads. So what SQL Server did to implement parallelism, it spun off 8 threads and they were working in parallel, and you can see the distribution is not very even across the threads, but that's fine. And you have thread 0, which is the controller thread. Now these 8 threads spent time on CPU, so the 561 milliseconds that you see is a cumulative sum of all these threads. And if you also want to look at something like actual time statistics, and you can see actual time in milliseconds. Wow, this is interesting. So you could see even this one. Only for this specific iterator, which is the clustered index scan, the same concept gets reinforced again because each iterator is spending time on CPU, and you can see the cumulative CPU time spent here is 61 milliseconds in comparison to the overall time, which is just 15 milliseconds. So what you saw in the messages tab was for the entire query, and this what you're seeing right now is only for that specific iterator. And here also you can see CPU time 67 milliseconds, and it actually wasn't like 67 milliseconds in serial fashion. It's not like first thread 5 milliseconds, then comes the next one. No, they're all working in parallel. So when 8 threads have spent X amount of milliseconds, you add all of that up, that makes it 67 milliseconds. And that's the same concept for the entire query. When 8 threads were working in parallel, and whatever time they spent on the CPU, that all gets added up in CPU time. So of course, CPU time can be more than elapsed time, and that happens when you see parallelism in action. Hope this video was useful, and hope your concepts are getting clearer. If you come across a question in any forum which is similar to CPU time, elapsed time, do not forget to paste the link of this video. Hope you learned something new. Happy SQL. If you like the content, give it a thumbs up, subscribe to the channel, and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.